Hello everyone. Today I will be presenting a detail on support vector machine, commonly known as SVM. SVM is one of the most powerful and widely used machine learning algorithm, especially for classification, pattern recognition, and data analysis. In this seminar, I will cover the definition of SVM, its basics concept, how it works, different types, and why it is used in real world applications. First, let's know about what is SVM. Support vector machine is a supervised learning algorithm used for both classification and regression tasks. However, it is most commonly used for classification problems. The main idea of SVM is simple but very powerful. SVM finds the best possible boundaries called a hyperplan that separates different classes of data. It tries to maximize the margin between these classes, which helps the model generalize better on new unseen data. Basics concept behind SVM. To understand SVM better, let's break down the core concept. First, hyperplan. A hyperplan is simply a decision boundary that separates data into classes. In 2D, it is a line. In 3D, it becomes a plane. In hyperdimension, it becomes a hyperplane. The goal of SVM is to find the best hyperplane that separates the classes with maximum margins. Next, margin. Margin is the distance between the hyperplan and the closest data points from each classes. SVM always try to choose the hyperplan with the largest margin because a larger margin, better generalization. Better generalization, better performance on unseen data. Support vectors. Support vectors are the critical data points that lies closest to the hyperplan. These points are important because they determine the position of the hyperplan. Only these points influence the boundaries. Removing them will all change the classifiers. So, the algorithm is named support vector machine because it depends mainly on these vectors. Next, a short history of SVM. The concept of SVM was introduced by Vladimir Vepnik and his colleague in 1963, but SVM becomes more popular during the 1990s when researchers introduced the kernel tricks, allowing SVM to solve nonlinear problems. Today, SVM is used in many machine learning applications such as text classifications, handwriting recognitions, image detection, bioinformatics, spam detections. Then, how SVM works? Let's break down the step by steps. Step 1, input data. We start with the data set containing two or more classes. Step 2, plot the data. We visualize the data in feature spaces. Step 3, find all possible hyperplans. There are many possible decision boundaries, but not all of them separate the data well. Step 4, choose the hyperplan with maximum margins. SVM selects the hyperplan that maximizes the distance between classes. Step 5, identify support vectors. Points closest to the hyperplan are identified. These points decide the width of the margin. Step 6, create the final model. The selected hyperplan became the final decision boundary. In mathematical equation, the equation of the hyperplan is w into x plus b is equal to 0, where w is weight vector, x is input feature, b refers to bias term. This equation helps to predict the class of any new data points. Next, we will see about types of SVM. Types of SVM is mainly categorized into two types. One is linear SVM and non-linear SVM. Used Linear SVM was used when data is linearly separable, meaning a straight line or plane can separate the classes. Its advantages was it is very simple, it works fast, it is easy to implement, works well when data is clean and clearly separable. For linear SVM, the examples are classifying emails as spam or not spam based on simple features. Next, let's see about non-linear SVM. It is used when data cannot be separated by a straight line. To solve this, SVM use a technique called the kernel trick. Let's see about kernel trick. Kernel function transforms low dimensional data into higher dimensional space. In this new space, the data becomes linearly separable. Common kernel includes polynomial kernel, radial bias function, and sigmoid kernel. This makes SVM highly flexible and capable of solving complex real-world problems. Let's see advantages of SVM. SVM has several benefits like works well with small data sets, effective in high dimensional spaces, resistant to overfitting, provide high accuracy, and can be used for both linear and non-linear problems. Next, limitations of SVM. Although SVM is powerful, it has some limitations like training time is high for large data sets. Then choosing the correct kernel is challenging, not suitable for noisy or overlapping data, hard to interpret compared to simpler algorithm. Let's see the SVM were used in real world applications. SVM is used in various real life areas such as face detection, handwriting recognition, text categorization, medical diagnosis, bioinformatics and gene classification, stock market prediction. This shows the versatility and importance of SVM in the machine learning field. Then, to conclude, support vector machine is a highly reliable and accurate algorithm that works well for both simple and complex problems. Its ability to maximize margin and use kernel function makes it unique and powerful. SVM continues to play an important role in modern machine learning applications such as classification, pattern recognition, and image processing. Okay, this is all about SVM. Thank you for listening to my seminar. Thank you.